Okay, hi and assalamualaikum. So let's discuss about the experiment, which is experiment 3 under topic energy. So the objective of the experiment is to verify the law of conservation of energy by using free fall motion. So according to this experiment, we are going to conduct something which is under free fall motion, and based on this we need to verify the law of conservation of energy. So how to verify it is quite simple. Normally we just compare two different values there. By getting equals values means that the law of conservation of energy already verified. Okay, but let's say the values getting out are different, so it doesn't obey the principle, so it's not verified lah. Okay. Alright, so what do we have now? This is the arrangement of the apparatus. Okay, what do we have? A ball bearing here, steel ball. And then we just put it at height h, and this is our starter and stopper. Okay, connected to the timer, starter and stopper. The distance between these two lasers now is s, so the distance are fixed already. Okay. Alright, so what happened now? First, consider a steel ball of mass m initially at rest at height h. Okay, so this is the height and this is the ball position. So this is our initial position. So at initial position, the ball doesn't move yet. So automatically V equal to 0, so that kinetic energy equals to 0. Then the energy contained by the body is mgh, which is our gravitational potential energy. Okay, so at initial position, what do we have? Just mgh, which is our potential energy, gravitational potential energy. So it doesn't move yet. V equal to 0, automatically kinetic energy equals to 0. When the steel ball is released, it falls freely with acceleration due to gravity g. At the instant it reaches the velocity detector, the gravitational potential energy is 0 and its kinetic energy is half mv squared. Okay, so this is our initial position and this is our final position. So by taking the final position as our lowest point, which is h equal to 0, means that mgh automatically equals to 0 because the ball already reaching the minimum height, isn't it? Okay, so the potential energy becomes 0 now. So what happened to the potential energy before? So 100% of potential energy at initial position here already converted to be kinetic energy because the object is moving faster, isn't it? Okay, at the this final position. So at the final position here, what do we have? The energy contained by the body is half mv squared, which is kinetic energy. So based on that, according to the principle of conservation of energy, sum of E final equal to sum of E initial. Okay, initially what do we have? Just mgh, and finally what do we have? Just half mv squared. And potential energy equals to kinetic energy. So mgh is the potential energy and half mv squared is the kinetic energy. M and M cancelling each other is giving you this equation. Okay, so based on this, we need to calculate the value of G. Okay, so by plotting a graph of V squared against H, so by comparing this equation with the linear graph equation, which is y equals to mx plus c, so V squared representing the y-axis, H representing the x-axis, so the gradient now equals to 2g. Okay, where the y-intercept supposedly equals to 0 lah. Okay, but it's not necessary to be 0. It depends on your data. Okay, so from the gradient, by plotting the graph, okay, which is V squared against H, and then from the gradient, which is equals to 2g, then we may calculate g, where g equals to m over 2. So m is the gradient lah. And then our theoretical g is 9.81. So by comparing these two values, by getting g equals to 9.81, which is equals to theoretical g, means that we have verified the principle of conservation of energy. But let's say G getting from the graph are different now, means that it doesn't verify. So this is the way. How do we verify the law of conservation of energy? Based on G. Okay. Alright. So now, according to this arrangement, S is a distance between our starter and stopper, isn't it? So this is our laser. When the ball just cuts off the laser, Okay, at the starter, what happened? The reading starts to be measured. And then when the ball just cuts off the laser at the stopper, what happened? The time stopped already. So we are measuring the times taken for the ball bearing for this distance actually, which is S. So S fixed already, okay? You need to measure S lah. Alright? Okay. And then, according to the procedure, okay, let's check the procedure. What do we have for the procedure? Okay, construct a velocity detector by sandwiching photo gates A and B using binding tape. Okay, we need to sandwiching these two photo gate, which is A and B. They are close to each other, so we need to measure the distance between these two lasers lah. Okay, and then measure the distance as between the photo gates. Set up the apparatus as shown in figure 3.1. Switch on the timer, reset to 0. Okay, as usual. Before this, I think we have used the timer. I think you know how to use the timer already. Okay, set the falling distance H at 15 centimeter. Okay, the first H is 15 centimeter, and then we just measure the times taken for the ball to move in this distance lah. Okay, and then for the second reading, we just increase by another 5 centimeter, again by another 5, by another 5, another 5, another 5, and another 5 centimeter. So we just increase H. Okay, so how many readings do we have? 1, 2, 3, 4, 5, 6, 7 readings there. So based on these 7 readings, and then we just complete the table, and then we just plot the graph. Okay, alright. So basically, what happened now? By increasing H, we just increase H from 15 to be 20, 25, 30, 35, 40, and 45, isn't it? So by increasing H, we have increased the potential energy, isn't it? Because mgh. When H increase, U also increase. So when you increase, K automatically increase here. Means that the ball bearing or steel ball here is moving faster. Okay? So basically by increasing H, the times taken for the ball bearing to pass through between A and B here should be shorter lah. The time becomes smaller. Okay, why? Because the speed increase. Okay, according to the principle of conservation of energy, by increasing H, the potential energy increase, so that kinetic energy also increase here. Alright, so the time taken should be smaller or shorter here, and then V should be increased. Okay, alright. So for this, okay, for each falling distance H, calculate the velocity using equation V equal to S over T. So S fixed already. T is the time measured here. Alright. Okay, so this is our table. I suggested table. Okay, first we need to measure the distance between these two lasers, which is S. Don't forget to measure S. And then this is the height. We have 7 different heights, isn't it? So we have 15, 20, 25, 30, 35, 40, and 45 centimeter. Okay, remember in 1 decimal places, should be 15.0, 20.0, 25.0, and others. Alright, and then this is the time taken here. Alright, so the time taken we need to repeat at least 2 times lah. For each reading, we need to repeat 2 times. Okay, this is T1 and this is T2 for each height. Alright, and this is the average. Okay, so how to calculate the average time? T1 plus T2 and then divide by 2. Okay, by getting T bar, this is the velocity. Velocity is S over T. Okay, so to ensure that the unit is meter per second, S must be in meter, because S measured before just in centimeters, isn't it? So in calculating the speed here, S should be converted to be in meter. Alright. Alright, so by converting S into meter, and T bar is the value measured or calculated before here, substitute into this equation and then you will get V. So remember, by increasing H, V supposedly increase. Okay, and then this is V squared. Okay, V squared should be meter squared per second squared for the unit. Okay, we just square all the values here and then you will get this. And according to this table, we need to plot a graph of, where is the graph before? The graph of, where is the graph? Okay, this is the graph, Wait, okay. We need to plot the graph of V squared against H. Okay, so this is our y component and this is our x component. So again, to make it easy, h we just convert it to be in meter because h measured before just in centimeter, isn't it? Okay, so now we just measured h to be in meter for the graph. Okay, so this is my suggestion lah. So meter squared per second squared divided by meter, giving you meter per second squared. That is the value of g. Okay, the unit of g. Alright, so from the equation given before, v squared equal to 2gh. So v squared against h, y against x. So the gradient are representing 2g, and the y-intercept supposedly equal to 0 lah. But it depends on your data. Okay, so m equals to g. So this is the equation. So that g equals to m over 2. What is m? M is the gradient of the graph. So as usual, please calculate the gradient. Okay, please refer to the decimal places used for each scale. Don't forget that, divide by 20 for both scale, which is x and y. Okay, so now from this, by rearrange the equations, g over m equals to 1 over 2. And we just transfer m to the other side, giving you g over m equal to 1 over 2. Okay, why? I want to show you this. Okay, g is m over 2. Automatically, delta g is delta m over m times g. Alright, so now g over m here, okay, g over m here equals to 1 over 2, still equals to delta m divided by 2, because g over m giving you 1 over 2. See? So this is the way how do we calculate delta g. So delta g is delta m over 2. So delta m is the uncertainty of the gradient. Okay, so we need to calculate this lah using the Excel given before. We just put the data into the Excel, and then you will get delta m. Substitute into this equation, and then you will get g. So this is the reading getting now, which is g plus minus delta g. What is our g and what is our delta g? Remember, the decimal places used now should be the same. Okay, and don't forget to calculate the percentage of difference, which is our g getting from the experiment, minus by theoretical g, divide by theoretical g, and multiply by 100%. So again, below 10% is nice. Okay, more than that, something is wrong. Okay, so this is the experiment for this week lah. So I hope you read everything here, make it clear. So by the next class, I think we may complete everything in 2 hours. Okay, all right. So for the discussion, okay, let me write for you later. Okay, all right, that's all for the experiment. Any problem, you may ask me. Okay, thank you. Assalamualaikum.